In this video, we are going to focus on factoring quadratic trinomials of the form ax squared plus bx plus c, where a is not equal to 1. So we're dealing with quadratic, second degree. Trinomial means 3 terms, where the leading coefficient is not equal to 1. In the previous video, we saw when we have a equal to 1, we did use the x method. And we could skip the middle step where we factor by grouping and quickly jump to the factors by looking at the special numbers we found in the x method. Now, when a is not equal to 1 in that case, things are a little different. So here's our first example, 8x squared minus 22x plus 5. So I'm going to show us two methods, and I'm happy with either one you pick. I will be usually picking the method 2 because I think it's faster. Okay, some part of the methods, both the methods, some portion is the same. So some of the portion is exactly the same in both of these methods. All right, so let's check our first example number 1. For method 1, our goal is to first of all, the directions say factor. Okay, it's not solving an equation. There's no equal sign in here. The very first step is to compare it to standard form of the quadratic equation, which is ax squared plus bx plus c, and figure out what is a equal to. A is 8, b is negative 22, c is positive 5. Next, we're going to do the x method. In the x method, like we did earlier, a times c goes on the top and b goes on the bottom. 8 times 5 is 40. A times c, 8 times 5 is 40, and b is negative 22. Now the search for two special numbers begin. What two numbers will multiply to give me 40, but they will add up to give me negative 22? Well, those numbers are going to be negative 2 and negative 20. So in the next step, I'm going to break the middle term into these two numbers that I just found. So the first term remains as it is. Instead of writing negative 22x, I'm going to write negative 2x minus 2x minus 20x plus 5. Now we have 4 terms and we will be factoring by grouping. So look at the first 2 terms. Is there anything common? What's the common factor in the first 2 terms? Looks like I could pull out a 2x, and that would be 4x minus 1. In the next 2 terms, the common factor looks like is negative 5. Always remember, this sign always comes down, whether it's negative or positive. Negative 5 times what gives you negative 20x? It's going to be 4x. Negative 5 times what gives you plus 5 would be negative 1. Now, both of these parentheses are same. That means it looks like my work is correct. So I can pull out the GCF. Now the GCF is a binomial, 4x minus 1. And I would be left with 2x minus 5 in another parentheses. And this is my final answer. These are the factors. So these two factors were multiplied to get to that polynomial that we started with. Now, one thing I didn't mention in the beginning, that always take out the GCF first. Before we do the x method, always take out the GCF first. You can take out the GCF at the end as well, but it's better to take it out in the very first step. You will be working with smaller numbers then. Okay. Now, how can you check if your work is correct? You can check by doing FOIL. FOIL means first, outer, inner, last. First times first is 8x squared. Outer times outer is negative 20x. Inner times inner is negative 2x. Last times last is positive 5. 8x squared minus 22x plus 5 once we combine the like terms, and that's what we started with. So we got it correct. Okay. Now in the second method, some part is same and some part is slightly different. Again, in this method, it's even more important that you take out the GCF first. First step is to take out the greatest common factor in your whole trinomial, if there is any. In this case, there's none. So 8x squared minus 22x plus 5, there's no GCF. Again, figure out your a, b, and c like we did in the last step. Negative 22 is my b, c is positive 5. Now it's time to do the X method. And this method is called bottoms up method. There's a lot of different names for this method, but I call it bottoms up method. In the bottoms up method, A times C goes on the top, B goes on the bottom. A times C is 8 times 5, which is 40, and B is negative 22. Again, like we did earlier, think about two numbers. They multiply to give you positive 40, add up to give you negative 22. They're going to be negative 2 and negative 20. Again, the order does not matter. In which order you write them does not make any difference. Now, in the bottoms up method, things are a little different at this point. So your first term is 8x. A is 8. So now we're going to divide both of them with the 8x. Whatever is your A, that number and an x attached to it. So divide both of them with 8x and 8x. Now it's time to simplify between the numerator and denominator. So that would be, we can divide both top and bottom with the 2 here. And we can divide both top and bottom with the 4 here in the second fraction. So this is where the bottoms up come into the picture. 4x minus 1 from bottom going to the top. And 2x minus 5. So there's my two factors, 4x minus 1, 2x minus 5. Again, you can check your answer by multiplying. We already did that in the previous method, so I'm not going to be doing that again. From now onwards, I'm going to be sticking with the bottoms up method because I think it's a little bit faster than the other method. But you feel free to use the one you like more. Okay, let's check out example number 2. I'll be erasing example number 1 and we'll look at example number 2. I'm going to show you only the bottoms up method from now onwards. Right, so let's compare to our ax squared plus bx plus c. A is 3, b is negative 25, c is 8. And again, we already checked out, is there any GCF here? Looks like there is no GCF. So make sure you check that first. If there is a GCF, pull it out first. Now for the bottoms up method, I'm going to draw my x. AC goes on the top, B goes on the bottom. 8 times 3 is 24, B is negative 25. Now, we are going to think of two numbers. They multiply to give you positive 24 and they add up to give you negative 25. And let's see what those numbers are. Okay, they're going to be negative 24 and negative 1. Again, I'm going to be using bottoms up method. Let's see, my first number was 3. And I have z squared over here. So I'm going to divide both of these numbers with the 3z and a 3z. Don't ask me why. It's just a trick that works. Okay. So let's see if I can simplify any of these fractions. I can simplify the first fraction. I can divide top and bottom with the 3. So that will leave me with 1z on the bottom and negative 8 on the top. Now for the bottoms up method, my factors will be g minus 8. And 3z minus 1. Okay. Again, for your own peace of mind, go ahead and check your work by doing the FOIL. FOIL means first, outer, inner, last. So first times first is 3z squared. Outer times outer is negative z. Inner times inner is negative 24z. Last times last is plus 8. So 3z squared minus 25z plus 8. And that's what we started with, and that's perfect. Okay, let's check out next example. We have checking is for your own peace of mind. Okay, it's not necessary, not required, but for your own peace of mind, you can check your answer. Check out number 3 now, and I'm gonna make a small change in number 3. I'm gonna make it an equation. I'm gonna say solve. So the only difference between a trinomial and an equation is trinomial would not have an equal sign and we would be asked to factor it, but an equation would have an equal sign and we would be asked to solve it. Okay, so let's go ahead and use our x method. A is 7, B is negative 4, C is negative 11, A times C is negative 77, B is negative 4. Two numbers that multiply to give you negative 77 add up to give you negative 4. Well, I can tell they're going to be 11 and 7. Which one should I make negative? 11 should be negative because now they will multiply to negative 77 and they will add up to -4. Okay, bottoms up method. Let's see what's what uh, what's the first term. 7x squared. So here's the trick. Divide with the 7x on both sides. Is it possible to simplify the first fraction? No. Is it possible to simplify the second fraction? Yes. So I'm going to go ahead and simplify the second fraction, and I would be left with, again, the bottoms up come into picture now. So my factors turn out to be 7x minus 11 times x plus 1 equal to 0. Remember the zero product property? If product of two factors is 0, one of them must be 0. Zero product property said, if product of two factors is 0, one of them must be 0. So that means either 7x minus 11 is 0 or x plus 1 is 0. So we're going to be adding 11 to both sides and divide both sides with 7 to isolate the x here. X comes out to be 11 over 7 and x comes out to be -1. Okay, there's our two possible answers here. So if x is 11 over 7 or if x is -1, then this equation will become true. All right, for number 4 as well, again, I'm going to make the directions as solve. First thing you want to look for is there GCF? Always, anytime you're factoring, look for GCF. That's the very first step. Here, I can see the GCF is 2x squared minus x minus 6. And then I'm going to make it equal to 0 because I said solve in the numerator. So now 2 is outside in the front because it's an equation. If it was a factoring problem, I could not make the 2 in the front disappear. But because it's solving an equation problem, we can go ahead and divide both sides with 2, because when you're dealing with an equation, you can divide both sides with the same number. That way, your life becomes easier. So we can go ahead and divide both sides with the same number, which is 2, and 0 divided by 2 is still 0, so that didn't change much. Now it's time to do the x method. A times c goes on the top, b goes on the bottom. 2 times, this was 2x squared. 2 times -6 is -12, b is -1. Two numbers that multiply to give you -12 and add up to give you -1 are -4 and 3. And my first number in this case is 2x and 2x. So I'm going to go ahead and write that, divide both sides with that. Looks like the second fraction cannot be simplified, but the first one can be simplified. So bottoms up tells me going from bottom to top, x minus 2 is one factor, 2x plus 3 is another factor. Now using the zero product property, says plug each factor equal to 0. Either x minus 2 is 0 or 2x plus 3 is 0. If x minus 2 is 0, then x is equal to 2. If 2x plus 3 is 0, then x is equal to -3 halves if you solve it for x. And there's our two answers for solving this quadratic equation. All right, let's see. There's two more problems. I'm going to make one of them. I will be leaving one as factor, the other one as solve. Okay, let's change the directions to this one as factor and change the directions to this one as solve and make it equal to 0. Okay, so for the factoring one, you can see there's no 0 on the other side, no equal sign. That means we won't have to use a zero product property. Okay, first thing we want to do is factor out the GCF. Is there a common factor in here? Nope, there's no common factor. There's no number that divides evenly with 30, 23, and 3. So I'm going to go ahead and do the x method. In the x method, a times c goes on the top, b goes on the bottom. 30 times 3 is 90, and b is -23. Think about two numbers that multiply to give you 90 and add up to -23. If you don't know your tables, you might have to play around with your calculator for a minute or two until you get the numbers that multiply to 90, add up to -23. You can make a table like this. Okay, 1 times what gives you 90? Well, 1 times 90. 2 times what gives you 90? 2 times 45. Is any way 2 and 45 can add and subtract up to 23, negative 23? No. 3 times what gives you 90? Okay, 3 times 30 is 90, but can they add or subtract to 23? No. 4 times what give you 90? Would be 4 times 2 is 8. 4 does not divide evenly with 90, so 4 doesn't divide. How about 5 times what gives you 90? 5 times 18 is 90. Can you get 23 out of 5 and 18 somehow? Yes, if I make both of them negative. Then they multiply to give me positive 90 and they add up to give me negative 23. There we go. Now don't forget your first number is 30, and we're going to be ending up dividing both sides with 30x and 30x. Okay, I'm going to clean this up a little, make it neater 30. Now let's go ahead and simplify the fractions and see if we can cancel anything between numerator and denominator. Looks like on the left hand side I can divide top and bottom with a 1, and the right hand side I can divide top and bottom with 18 and 30 with the 6. 6 times 3 is 18, 6 times 5 is 30. Now comes the bottoms up method, which would be 6x minus 1 and then 5x minus 3. Again, you can check by doing FOIL to make sure you get it correct. Otherwise, that checking is for your own peace of mind. Sometimes I catch students using guess and check method. I highly discourage you from using guess and check. I do not recommend guess and check because a lot of times people guess and they don't check. And that doesn't give you the right polynomial back that you started with. Let's check out example number 6 now. For number 6, we do have a common factor. The common factor is x in this case. So I am left with 2x squared plus 13x plus 15 equal to 0. And inside is the kind of trinomial that I can handle with bottoms up method. So I'm going to go ahead and do bottoms up for inside trinomial. A times c would be 15 times 2, which is 30. And b is 13. Two numbers that multiply to give you 30 and add up to give you 13 are 10 and 3. We're going to divide both of them with a 2x and a 2x. All right, so there's a 5. Here we are. We still have the x outside in the front. Do not drop that x. If it was a number 2, 3, or 4, and I was dealing with an equation, I could divide both sides with that number. But now I have a variable, and you cannot divide both sides with the variable because you will lose some solutions, okay? Now bottoms up is telling me this is going to give me the factor x plus 5, and this is going to give me the factor 2x plus 3 equal to 0. When product of three things is 0, one of them must be 0. Either the x is 0, or x plus 5 is 0, or 2x plus 3 is 0. Okay, so I have either x is 0, make a nicer equal sign, either x is 0 or x is negative 5, or from here if you try to solve, you get 2x is negative 3, which means x is negative 3 halves. So 3 possible answers here. Usually, whatever is a degree of your equation, that's how many solutions you are going to get. Some solutions can be repeating, so you may not have that many distinct solutions, but in most cases you will have that many distinct solutions as the degree of the polynomial is. Okay, there's also some polynomials that are prime, that are not factorable. Let's think about, let me make one up that is prime. So I'm just gonna come up with one, which is 8x squared plus 22x minus 5. I'm just making one up now, and I'm going to call it example number 7. And it says factor. So 8x squared plus 22x minus 5. Let's see if it is prime. I'm going to do the x method. 8 times 5 is negative 40, and there's 22. Can you think of two numbers that give you multiply to give you negative 40, but they add up to give you positive 22? I don't think so. Well, 20 and 22 do. If I make them both negative, they won't multiply to give me positive 40. They won't multiply to give me negative 40. But if I make one of them negative, if I make both of them negative, then they will multiply to positive 40. But if I make one of them negative, then they won't add up to 22. Okay, so you can try playing around with different numbers and you will see there isn't a pair that will multiply to give me 40, negative 40, and add up to give me positive 22. So that means this polynomial is prime. It's not factorable. Sometimes we call it not factorable. Prime also means not factorable. All right, that's end for this video.